Have you ever just looked at a massive bridge and wondered how did they get those two ends to meet perfectly in the middle? Or even just your own backyard? How does anyone know exactly where your property line is? Well, it's not magic. It's this ancient art and science that literally builds the invisible framework of our world. So today, let's dive into the fascinating field of surveying.
Really, it all boils down to this one fundamental question. How in the world do we measure the world? I mean, think about it. Whether it's something as simple as laying out a new garden, or something as massive as planning a highway or the foundation for a skyscraper, we have to have a way to accurately map out where everything is.
And the answer to that big question is surveying. Officially, it's the art of figuring out the relative positions of different points by measuring distance, direction, and elevation. You know, it's basically the science that takes our messy, three-dimensional world and turns it into an orderly, understandable plan. But how is that even possible on a grand scale?
Well, it turns out the entire field, all of it, is built on two incredibly simple but really powerful principles. You could call them the golden rules. These are what allows surveyors to measure huge areas with just mind-boggling accuracy. So let's break them down.
Okay, first up, principle number 1. Now, this one might sound a little backwards at first, but trust me, it is the absolute key to making sure huge projects don't end in total disaster.
And here it is. Always work from the whole to the part. So instead of starting with little details and hoping they all just kind of add up correctly, surveyors do the exact opposite. They start big, establishing this large, super precise framework of points that covers the entire area they need to map.
And the way this prevents errors is just genius. First, they lock in those major points with extreme accuracy. Then, they fill in that huge area with a network of big, reliable triangles. It's only after that main skeleton is absolutely perfect that they start breaking it down into smaller and smaller triangles to fill in the finer details. And here's the brilliant part. Any small measurement error gets trapped inside one of those little triangles. It keeps a tiny mistake from spreading and, snowballing until the whole map is a mess.
Okay, so that's how you control for error over a big area. But how do you actually locate a new point with total certainty? Well, that brings us to our second golden rule.
And the rule is simple. You have to locate a new point by measuring from at least 2 other points that you already know. I mean, think about it for a sec. If you only measure from one known spot, your new point could be anywhere in a circle around it. But the moment you measure from a second known spot, there's only one possible place where those 2 measurements can cross. Bam! That's how surveyors fix a new position with absolute confidence.
So, with those 2 rules in their back pocket, surveyors can get to work. But first, they have to make this really fundamental choice that might surprise you. They have to decide, are we treating the Earth as flat or as a giant sphere?
And that decision splits surveying into 2 main types. On one hand, for smaller projects like a construction site or maybe a city park, they use what's called plane surveying. They just assume the Earth is flat, because over a small area, the curve is so tiny it really doesn't matter. But for the really big stuff, like mapping an entire country, they have to use geodetic surveying. That's where they take the Earth's curve into account and use much more complex math to get it right.
All right, so once a surveyor has their principles down and they've picked their method, what do they actually make? What's the end result of all this measuring? Let's take a look at the actual maps they produce. The main goal here is to create these incredibly detailed and accurate maps. And we're not talking about your average road atlas. These are specialized documents that are used for everything from huge construction projects to legal decisions about land. For instance, a topographical map shows you the actual shape of the land, all the hills, valleys, and rivers you'd see if you were hiking. Then you have cadastral maps, which are super important because they define the legal property lines for houses and fields. Engineering maps have all the critical data needed to build stuff like roads and bridges. And marine surveys, well, they map the ocean floor. Every single one is a product of this precise work.
So, we've talked a lot about mapping points in 2 dimensions, like on a flat piece of paper, the X and the Y. But what about the 3rd dimension? What about height? How do we measure elevation? This is where another crucial piece of the puzzle comes into play. It's a whole branch of surveying called leveling, and its entire job is to figure out the vertical distance, the height, of different points, all based on some known reference point, which they call a datum. This is exactly how we know how high a mountain is, or the perfect slope for a road so that water drains off of it.
So how does it actually work? It's actually brilliantly simple. A surveyor starts at a point where they already know the height. They take a reading there, that's called a backsite.
They add that reading to the known height, and that tells them exactly how high up their instrument is. Then they just turn to the new point, take a reading there, the foresight, and subtract it from their instrument height. And just like that, they have the precise elevation of the new spot. It's this simple, elegant process that they just repeat over and over again.
Which, brings us right back to where we started. Whether it's working from the whole to the part, or using 2 reference points, or calculating height through leveling, it all serves this one core purpose, to precisely figure out where things are in our world. So the next time you look at a skyscraper, or drive down a highway, or even just stand in your own yard, take a second to think about the invisible framework that makes all of it possible. Every single boundary, every foundation, every single slope was first defined by this quiet, precise art. It really makes you wonder, doesn't it? What other invisible systems are shaping the world around us right now?